Okay, done. So let's start the session. So in the last class, we have seen what is meant by statistics, which is nothing but measuring plus analysis. First, we have to measure the data, and after that, from that, we are going to analyze the data, which is called as analysis, statistical analysis, right? Statistical analysis means where statistics means with respect to, first we have to measure the data. First we have to collect the data and we have to measure the data. What is the data we are going to measure means minimum value, maximum value, or with respect to average value, all these things, right? Done. Now here the population, whatever the population is, entire population, the complete data is called as population. Okay, the entire data is called as population data, and sample data means subset of the data is called as sample data, right? Now, we have seen with respect to multiple examples for population, the complete data is called as population and a subset of population is called as sample. And why we are going to use this sample means it is less time consuming and it is less costly. And along with that, if we are having only option is this one. To be more real means with respect to this is the only option because we are not able to get the entire population data. It is highly impossible to get in the real life with respect to the complete data, right? Now, coming to the statistics, we are having the inferential statistics and descriptive statistics. Now, what is meant by descriptive statistics means collecting and presenting and describing the data is called as descriptive statistics. Means whatever the minimum value, maximum value, average value, all these values, for calculating that values, first you have to collect the data. First you have to collect the data. So in this class, what is the minimum age of the student? What is the maximum age of the student? Means first I have to collect the age of the students, all the students' ages. And whatever the ages of the students have collected, just I'm going to describe them. That is the minimum value, this is the maximum value, this is the average value. Like this, something I'm going to describe, right? So as of now, I'm saying minimum, maximum, and average because you already know these three terms. Remaining terms, which we are going to discuss in the statistics. Okay. Now, presenting, we are having different types of data. That is continuous, any structured data. We have already seen with respect to okay, any structured data, whatever the structured data we are having, any structured data is of one, cross-sectional data, and the second one is time series data. So within the cross-sectional data, we are having continuous and discrete. For time series, we are having only time series. So totally in the structured data, what are the different types of data we are having in the structured means that is in the tabular format. Whatever the data we are having in the tabular format, within that each column, within that structured data, each column in structured data, what is meant by structured data? Which don't say in the tab, it is called as table. Don't say tabular data, which is in the table format. Don't say this one. This is not the right answer. Which is having a proper format. Structured data means which has proper format. This is the answer. That format you are creating using a table. Okay. The answer is which is having a proper format, some systematic format, or some rules are there for that. That format is having some rules. Which format is having the rules or proper format or proper structure? That one is called as structured data, right? And it is represented in the tabular format, so it is called as tabular data also. This is second option. This is second point. First point is this one. Major point is this one, right? Now in the structured data, whatever the structured data we are having, in the structured data, we are having multiple columns are there. Multiple columns. The column names, for multiple columns, we are having column names. The column names in statistics called as variables. In statistics, they are called as variable. Okay, each column name, example, age, education, right? Your phone number, your mail ID, everything. Whatever the column name is there, the column name is called as variable. Generally, in the structured data, the variable will be of three types. One is of continuous variable, or let us start. First one is called as discrete variable. The first one is called as discrete variable. Second one is called as continuous variable. Third one is called as time series variable. Generally, in a structured data, we'll have only three variables, either of these three. Any discrete variable will be there, or continuous variable will be, or time series variable will be. None of apart from this, none of the variable will be available in the structured data. Within structured data, unstructured data concept is entirely different. For unstructured data, the statistics is entirely different, or the analysis is entirely different. Completely, it is a different one. Okay. For discrete or continuous or time series, for discrete variable, we are going to do the discrete analysis. For continuous variable, we are going to do the continuous analysis. For time series variable, we are going to do the time series analysis. For each type of variable, we are going to do the analysis. So for each variable, we analyze the data. For each variable, we analyze the data is known as analyzing the each and every variable of the data. Simply to say, analyzing each variable of data. Analyzing each variable of data is known as exploratory data analysis. Exploratory data analysis, which is called as shortcut of EDA, which is the most important. And in the real life, we are going to spend 40% of our project time in this only. 40% of the project time will be spent on this. Almost 4 weeks we are going to spend, really almost close to 1 month. Okay. For 1 month, we are going to do only EDA part. Now, what is meant by EDA? EDA means nothing but exploratory data analysis, full form. What is meant by exploratory? Exploratory means explaining. Exploratory means explaining. Data analysis means explaining each data clearly. Explaining the data clearly is called as exploratory data analysis. You have to explain the data very clearly. What is the data and how the data is there, and what is the things. For doing this one, the statistics is the most important part. How we are going to explain means statistical way we have to explain. We are not explaining as per our own choice. We are going to explain everything as per the statistical way. Why we have to explain to statistical way? Because that is a proper measuring numbers. Statistics are proper measuring numbers. If you're not explaining through statistics, as per your choice, you're explaining means there is no proper format for that. Statistics is a proper measurement. It is a proper measure analysis. Okay. Now, in the statistics and max, what is the difference between stats and max? Max means doing plus and minus is called as max. Doing for which one plus and minus is called as statistics. Where we have to apply plus, where we have to apply max, minus, and which variables we have to add, which variables we have to delete. All these things is called as stats. Right. Now, explaining each data clearly is called as your exploratory data analysis. How we are going to explain? By using continuous data analysis to discrete data analysis, 3 time series analysis. Each variable we are going to select and we are going to analyze. For continuous, first you have to separate the continuous variable. How we have to separate? That you have to see in the df.d types, or you can see in the d types or df.info. In the info, you know that each and every variable data type, right? And you are going to check whether these variable data types are correctly given or not. Everything you are going to check with respect to the names. And if there is a age column, which is int only is there, still you are going to understand it is a continuous variable. And you have to mention that one in the, take the continuous list of variables in the continuous list. Okay, whatever the given data is there. In the given data, let us assume there are total 30 variables are there. In these 30 variables, how many variables are continuous? Take the names, variable names in a list. And discrete variable, create a list. For time series, create a list. You have separated the each and every variables. Whatever the variables are available in the given data, you have separated them. What are continuous variables you have separated? What are discrete variables you have separated? Now you have to start separate analysis for this one. You have to do the separate analysis for this one. Right? Now, for discrete variable, we have to do a different analysis. Okay. Coming to descriptive statistics means collecting, presenting, and describing the data. Inferential statistics means whatever the based on the sample, we are estimating the population, because I already told you that collecting the population data is highly impossible. We can't get the entire population data in the real life. Practically, it is not possible. For small data sets, everything is possible. We are not discussing about the small data sets. So only 10 students means anything is possible with 10 students. With the 1,000 students in the class, that is the task. Controlling 1,000 students is different. Controlling 10 students is different. Focusing on 10 students is different. Focusing on 1,000 students is different. Analyzing 10 students is different. Analyzing 1,000 students is different. Right? Here, Getting on the small data set, if you are having a small data set of 10 records, then the population data, sample data, no matter what happens, that is small data, it will not have any impact. When you are working on the large amount of data, at the time, population is very difficult to collect. So in that case, we'll go on the sample only. Always we'll work in the real life using the sample, completely on the sample. Now, within this sample, whatever the sample we are working, based on the sample, we are going to estimate the population values. For example, in this class, I'm having total 150 students are there. Let us assume there are 150 students are there. Now, out of these 150 students or 100 students, let us take 100 students. I'm going to take a sample from this 100 students. I'm going to take sample of 10 students. And I'm going to take the feedback rating of these 10 students. And these 10 students has given me a feedback rating of 4.85 out of 5. Assume this is the rating was given. Now, this rating was given by these 10 students, not with respect to 100 students. Remaining 90 students also may give the same rating, may give a different rating, and some of them may give with respect to 1 out of 5. Some of them may give 5 out of 5. Anything can be possible. That can be possible, or this can be also possible. But now, for example, I'm having with respect to a rating of 4.85 with respect to 5 rating. Now, this is the sample rating, average of sample data. Now, based on this, I have to estimate all the remaining 100 students, what is their feeling. Now, the same, whatever the answer I have got 4.85 out of 5, I can't think myself, the population value also the same value. Population value can be less and can be more also. Anything can happen. For example, remaining 90 students are there. Everyone are giving 5 out of 5 only, assume. Now, what happens in this case? Automatically, the rating will be more than 4.85 only, right? If, for example, in this, these 90 students has given me only 4 out of 5, every student has given me 4 out of 5 only, then in that case, it is going to be less. Anything can happen. But based on the sample, whatever the based on the sample I have received, based on the sample, I'm going to estimate the population. In the real life, the data analyst or a quality inspector, for example, there is a quality inspector. He is going to a manufacturing company. The manufacturing company is Kinley water bottles. So a quality inspector has went to a Kinley water bottle company, and there he is going to inspect the bottles. The water quality is different. I'm not discussing about the water quality. So he's going to inspect that whatever the 1 liter water bottle is there, you're mentioning on the sticker that 1 liter. This water bottle consists of 1 liter. But inside 1 liter is there or 990 ml only is there? 990 ml is there means that is not going to impact you, because 10 ml you can't find the difference. But if I manufacture the same 10 ml of 100 bottles, I can get 1 more liter as free. Right? Now here, if it is consisting of only 990 ml, or if it is consisting of 1000 ml or not. Now, from quality inspector, he is going to check. For example, he has went to a manufacturing company. There almost 1 lakh bodies are available. He is going to check all the 1 lakh bodies. Is that possible? To open all the 1 lakh bodies and check inside that every water bottle 1000 ml is there or 1000 ml is there. To check like that, it is possible. No, he's going to randomly select 1 case of bottles. That is 100 bottles. He is going to select. In every 1 case, 100 bodies are there. Means just he is going to select randomly 1 case, out of which 100 bodies he is going to select. For this 100 bodies, he is going to do some kind of analysis. And based on these 100 bodies, he is going to estimate the 1 lakh bodies, remaining 1 lakh bodies, what is there. So that is called as inferential statistics. Estimating based on the sample, the population is called as inferential statistics. Right? In the real life, we have to apply inferential statistics only. So for example, one more example, COVID. In the COVID, we have got the co-shield and co-shield injection and co-vaccine injection. It is applicable for everyone. Some of them has got the body pains. Some of them has got the fever. Some of them has not got anything. Because why? Though the age is same. For example, 3 persons are there. 3 person age is 28 only. 3 of them are male only. And for 1 person, I have given the 3 persons we have given the injection. Out of 3 of them, 1 person has got the fever and 1 person has got the body pains and 1 person has nothing feeling. He has not even taken the rest for even for half an hour or 1 hour also. He has went for his work normally. 1 person for 2 days, he has taken a leave, completely having some kind of fever or body pains or something like this. Assume. Now, why this changes? Because based on the body composition. In the body, we are having sodium percentage with respect to calcium percentage, or some chemicals are there in the body. Now, every person will have that one, but the percentages are different, right? Vitamin C percentage of yours and percentage of me, for me, it is different. Calcium percentage, or if you say sodium percentage, person to person, it differs. So that is the reason when this injection was injected, inside the body, some chemical reactions, the differences there. right? Now, but this medicine, who has invented the medicine, that is some company, that is Covaxin or Covishield, whatever the medicine they have released in the market, they have injected to some people. They have done a sample of certain people and they have released into the market with 130 crores. For the entire population, they have released that one. For 130 crores, they have released them into the market. But on the sample, how many people they have tested? Means not even 1 lakh. Not even 1 lakh people they have tested. Based on these 1 lakh testing results, they have inferred for this 130 crores, sorry, 130 crores people, this is the estimated things. And they have released in the market. If you see the entire documentation, you can read this, all the things, right? In the future, you'll understand the documentation also. As of now, you may not understand, but in the future, you'll understand so much of documentations of data analysis documentations, right? Now, data, as I have told you, the variables are there, different types of variables, that is a discrete variable and continuous variable, right? In the discrete categorical variables. And we have discussed for the discrete variables, different types of plots, which are called as bar plot and pie plot. Bar plot is used for with respect to count or frequency, to represent the frequency or count. Whereas pie chart is used for representing the percentage. Whenever there is a percentage, how much percentage of people are there, like this, you can represent by using the pie chart. So this is to representation of frequency of discrete variable, and this is the representation of percentage of the same variable, discrete variable. And in the last class, we have discussed what is probability. And we also discussed discrete probability distribution, right? That is on the Saturday's class, right? Now, here, when you'll start the matplotlib and C1, when the time comes, then I'll start. When I have to tell the matplotlib, then I'll start that one. Simple answer. Right? Now, coming to the continuous variable. Okay. Now, the same thing, whatever we have done, an example we have taken related to gender. In the gender, we are having with respect to males and females. What are the males and females are there? Males, female, male, male, female, male, female. Right? We are having something like this, values. Now, using these values, we are representing them in the bar plot, like this, males and females. What are the males and females we are having? We are just representing the same thing in a bar plot, where we are taking on the y-axis the frequency, on the x-axis the categories. Why categories we are considering? Because this is a discrete variable. For discrete variable on the x-axis, you have to consider the categories, whatever the categories are there. Now comes to the continuous variable. Now let us see the continuous variable. Now here we are having with respect to the continuous variable, right? Whatever the continuous variable, that is 90, 100, 108, 99. This is the weights of the students. Whatever the weights of students we are having. Now, in this weights of the students, now these are the weights of 20 students. Okay, their weights, whatever the weights they are having in terms of LBs, not in terms of kgs, right? So here I'm having the weights of the different students in terms of LBs. Now, this entire data, now weight comes with respect to continuous variable or discrete count variable. Here, the weight in this data set, it is a 100 or 108 or 99. But can you tell me weight can be with respect to decimals is possible or no? Possible, right? Decimals also possible. And that too, these 20 students, if you draw with each kg, that is 90, after that 91, 92, 93, 94, 95, like this from 92, what is the maximum value? 130, 138. So from 90 to 138, you have to draw 1 bar for each of them. If you consider as a discrete variable, assume that you are considering this one as a discrete variable. Now for each category, you have to take 1 bar. For 90, you have to draw 1 bar. For 91, 1 bar. 92, 1 bar. 93, 1 bar. 94, 1 bar. 95, 1 bar. Like that up to 138, you have to draw. So what is the use of selecting of each bar like that? So now second point is, here the weight is a continuous variable. Now for continuous variable, how we are going to represent them? For bar plot, we are going to use. Now the same thing, how we are going to represent the continuous variable means, the continuous variable we are going to represent by using the continuous frequency distribution. Same, once again, the same plot I'm going to draw. Here, the plot, whatever the bars are there, I'm going to attach the bars from 90 to 100. I'm going to take some size, some interval. These are called as intervals. I'm going to consider some certain amount of intervals, and based on the intervals, I'm going to select the values. So here, what are the intervals I have selected is 10 as the interval. Why you have selected 10 as the interval means, how you select the intervals means simple, very simple. The formula for interval is maximum value minus minimum value divided by number of intervals you want. How many number of intervals you want? number of bars you want, or number of intervals. Both are same. Correct. Now interval size, each interval size is equal to maximum minus minimum divided by total number of intervals. Each bar, this interval is also called as bar. But in the bar plot, it is called as bar. In the continuous variable, this one also it is called as bar, means the people are getting confused. So that is the reason they have created for this one called as bin. For this continuous variable, this is called as this. Each one is called as, generally it is called as bar only. But for continuous variable, it is called as bin, because not to confuse with respect to bar plot. So now the bin size, your bin size is equal to each bin size, how much width you want to take. Height is already fixed. Height is based on the frequency. Height we can't change. The bin size is equal to maximum value minus minimum value divided by number of bins. Number of bins. Right? Now, how that is C. Here, in this case, I'm going to check what is the maximum value, 138. Okay. Now, the bin size is equal to, in this example, 138 minus minimum value is 90 divided by, you can take your number of bins. By default, the number of bins are 10. In the Matplotlib or Seaborn, if you apply this kind of graph, by default, it is going to tell it the 10. Default value. Default value is 10. No, sir, you don't want 10. Choice is yours. You can write whatever the number you want. By default, it is going to take 10. So, for example, if I'm considering here 10 means nothing but 48 divided by 10, which is 4.8. Each bin size is going to be 4.8 exactly. If you're considering the bin size of 5, number of bins of 5, then you are going to get each of them of 9.8 only, yeah? 9.6. 9.6. You are going to get each bin size of 9.6. Here, I'm going to take with respect to each bin size of 10. In this example, I'm selecting the bin size of 10. Right? Now, here, whatever the interval I'm having, the bin size with respect to 10, from 90 to 100, how many students are there? On y-axis, I'm going to take the students. Okay, from 100 to 110, how many number of students are there? 100 to 120. Now, first, whatever the data I'm having, this is the data. First, write this data in your notes. Write the data in your notes, because the same example I'm going to continue in the further entire PPT. So please write these values: 90, 100, 108, 99. Write these values in your notes. Just take one column. In that column, just mention all the values. Column or as per your choice. Lazy people, take the screenshots. That is also as per your choice. Don't draw the diagram. Just take only the data set. Just take the data set only. Don't draw the diagram. How to dot this one and what is the meaning of this one and how you got that one. Everything we are going to discuss. That is most important. Done? 20 values. Done, guys? Now, I am also writing myself because I will also erase now. Done. So here we are having with respect to these values, what are the values we are having? From these values, first step, we are going to create a called as frequency table. First step, we are going to create a table. What is meant by frequency table means just you have to take a table. Just you have to take a table. Where table, first you are going to take the interval and the second one is frequency. What are the frequency? Interval is 90 to 100, 100 to 110, 110 to 120, 120 to 130, 130 to 140. This is called as frequency table. Now, let us observe how many of them are there from 90 to 100. 100 is not included in this bar. By default, the right side part is not included in the each bin except the last one. For last one, automatically it has to be included. Okay, for the last one, it will be included. Apart from the last one, none of them will be included, right? So by default, the last one is not included, right? So here we are going to take with respect to 100 to 110, 110 to 120, 120 to 130, 130 to 140, 140 to 150. By convention, the right endpoint is not included. Okay, now you'll get a question. Sir, anyways, right part is not included now. Then you can take 110 to 119 only, right? Why to take 120? 119 only, you can stop. 120 you keep in the next bar. Then if there is a value of 119.7, where you keep? Okay, sir, 119.9 you keep. Then 199.97 is there. Then where you keep? Continuous variable means right side decimal value can be anything, right? So that is the reason they'll consider continuous. That is the reason they'll continue. Continue means the bars are attached. For example, if you write like this, 100 to 119 only. 100 to 119, this is the bar means the second bar starts with respect to 120. Here the bars are not getting attached, right? In between them, at least 1 mm gap is there, right? Something gap is there, right? So here there will be no gap. Continuously, all the bars gets attached. All the bars are attached side to side, right? So here, whatever the things we are having, just so based on this, we are going to create the plot, right? The plot, what we are going to use means from 90 to 100, how many values are there? 1, 2, 3, 4, 5. 5 values are there. Next, 100 to 110. 110 should not be included, but 100 should be included. 1, 2, 3, 4, 5, 6. 6 values. Next, 110 to 120. 1, 2, 3, 4. Next, 120 to 130. 1, 2, only 2. 3. Next, 130 to 140. 1, 2. These are the two. So now the same thing, whatever the frequency table you have got, the same thing you represent on the bar. Take this interval on the x-axis, 90 to 100, 100 to 110, 110 to 120, 120 to 130, 130 to 140. Whatever the intervals you have got, the same intervals you have to write on the x-axis. X-axis is intervals. Y-axis is nothing but frequency. So 1, 2, 3, 4, 5, 6. So from 1 to 9, from up to 5, wherever the height of 5 is there, that is 1, 2, 3, 4, 5. Height of 5, you have to draw this bar. From up to height of 6, you have to draw the second bar. Up to height of 4, you have to draw the third bar. Up to height of 3, you have to draw the next bar. Up to height of 2, you have to draw the next bar. This is called as distribution. This entire data you are representing here. This entire data you are representing in this plot, which is also called as, again, frequency distribution. This is also called as frequency distribution. Since we are applying on the continuous variable, so it is called as continuous frequency distribution. This is frequency distribution. How we have discussed the discrete frequency distribution, similar way, this is continuous variable. So for continuous frequency distribution, the continuous frequency distribution is also called as histogram. This is also called as histogram. The technical word is called as histogram. Histogram is nothing but continuous frequency distribution. On the x-axis, you are representing your bins. On the y-axis, you are representing the frequency. Right? So just first you have to take the frequency table. From the frequency table, you have to draw this one. Is that clear? Done. Next, we are having for time series variable. Time series variable, as the time changes, how the value changes. Okay, as the time changes, how the value changes, that is called as time series variable, where we are going to represent by using a line plot. By using a line plot. On the x-axis, we have to take the time. On the y-axis, we have to take the value, which is called as line plot. By using a line, we have to represent. Well, for any in the real life, in the stock market, that is any particular company share, as the time changes, how the share value changes is represented by using a line plot. Okay, in Amirpet, that traffic at morning 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, 1 o'clock, 2 o'clock, like this. As the time changes, how the value is getting changed. Your traffic means in terms of number of vehicles. Number of vehicles passing the signal. More number of vehicles passing the signal means more traffic is there. Less number of vehicles are passing means less traffic is there. Traffic is given as with respect to number of vehicles, right? So here just we are going to count the number of vehicles. As time changes, the number of vehicles are increasing or decreasing. So that we are representing by using a line plot. So the time series variable will be represented by using a line plot. So for different types of data, we are having different types of plots are there. We can't apply for everything on the same, right? Is that clear, guys? Now, as we discussed, we are having population. One is population and one is sample. Whatever the population parameters we are going to calculate, they are called as parameters. For example, if you calculate average, what average? Sample average or population average? Population average means then this average is called as parameter. Same average. But for if you are calculating the same average value for a sample data, if you are calculating for a sample data, then the same average is called as statistic. Okay. Then it is called as statistic. Same thing. Both are same. For example, if I say in a flow average value, but what average? Sir is saying average. But sir, what average sir is saying? If I say that sample mean statistic, if I say mean statistic value, means automatically you'll understand what is that mean statistic means? Sample mean only, right? If I say mean parameter, automatically you'll understand that is a population mean. Mean means nothing but average. Average in the max, statistics it is called as mean. Both are same. Right? Now, we are having in the statistics, we are having the business, the entire statistics. We are going to describe the descriptive statistics. Is that right? Descriptive statistics. What are the descriptive statistics means? Describing the data. Describing the data is called as descriptive statistics. How we are going to describe the data means by using 4 business moments. The first business moment. The first business moment is called as first business moment. Second one is called as second business moment. Third one is called as third business moment and fourth business moment. By using these 4, we are going to measure the entire data. The entire data we are going to measure based on these 4 values. The first business moment is measures of central tendency. Measures of central tendency. The second business moment is measures of spread or distribution. Measures of spread or distribution. It is going to measure the entire distribution. How the entire data was distributed. Third one is called as, third and fourth, both of them are used for measures of shape. Third and fourth one are using measures of shape. They are going to measure the shape, how the shape of the distribution is there. Okay, measures of shape, where this third business moment is going to use skewness. And fourth one is kurtosis, but both of them are with respect to measures of shape. Now, let us see what is measures of central tendency. In the measures of central tendency, we are having mean, median, and mode. These 3 of them comes under measures of central tendency. Mean, median, and mode. Next, measures of spread or distribution. What are the things we are going to measure? Miss, what is minimum value, maximum value, range value, variance, standard deviation, interquartile range. These are the things which we are going to measure. Percentiles, quartiles. These are measures of spread or distribution. That third one, measures of shape, out of which the third business moment is skewness. Within the fourth business moment, it is called as kurtosis. If you understand all these 4, the descriptive statistics is completed. Right? Then we'll move on to the inferential statistics. So these are the 4 things which we have to measure. These are called as measures. Analyzing is different. Measures are these. So here in the first business moment, we are going to measure the mean, median, and mode. In the second business moment, we are going to measure the range, variance, standard deviation, IQR, interquartile range. Full form is interquartile. That we'll see one by one. Percentiles, quartiles, right? So let us start with first business moment. That is measures of central tendency. Let us start with respect to the first one, which is called as measures of central tendency. In the measures of central tendency, we are having mean, median, mode. Let us take for this data set. This is the data set. So for this data set, we are having with respect to 154, 139, 154, 192, 180, 140, 154, 155, 192 centimeters. We are having, this is the heights of the students. Let us take the heights of the students. I am having a data set. Total 9 values are there. For these 9 values, whatever the data set I am having, first I am going to calculate the median. Now, what is meant by median? Median means centermost value of the ordered array. It is the middle value of the ordered data set. Middle value, center value. That is the reason it is called as measures of central tendency. Central tendency means center value we are going to measure. Here, we are going to focus only on the value of the center position. For example, let us assume there are 5 chairs are there. Total 5 chairs are there. In this 5 chairs, what is median means center position chair, whatever it is there, that is called as median by default. In that chair, who is going to sit? That is not important for me. Value is not important. Inside this, whatever the value is there, I'm not focusing on the value. I'm focusing only on the position. Median, what is the difference between the median and mean is, this is the difference. Mean will focus on the value. Median will focus on the position. In the center position, whatever the value is there, that value is called as median. Irrespective of whether it is a low value or high value, whatever it is. Sitting in the middle position means that is the thing. Fix. Okay. So median is middle value of a ordered data set. Middle, write in the notes what is meant by median. Median means center, median means center position value. Underline the position. Position is important for me, not the value. Whatever is there in the center position. For calculating the center position, in the original data set, we are not going to do that one. First, we have to convert to an ordered data. That is either increasing order or decreasing order. Anything as per your choice. For anything, the value is not going to change. The value remains in the center position only. So center position value, whatever the value is in the center position of the given data is called as median. So here, this is the data. First, I'm going to convert this one as an ordered data, which is an ascending order. In this ascending order, total 9 values are there. In this center position is 154. So the median is equal to 154. And you can get the which value you have to calculate. Sir, here total 9 values are there. So directly you are seeing the center position. This is the center one because here 4, here 4. If you remind, center one is this one. Okay, simple data set, 9 values only is there. Assume there are 100 values or 1000 values or 10,000 values or 5,944 values. 5,944 values are there. In that, out of which center position value, how to calculate? Any value you can calculate by using n plus 1. The position you are going to get n plus 1 divided by 2. So here the total number of count is 9. 9 plus 1 divided by 2, which is 10 by 2, which is the 5th position is your median value. Whatever the value is in the 5th position, 1, 2, 3, 4, 5. 5th position is this one. So it is the median value. This position, you are going to get the position of the median by using the formula of n plus 1 divided by 2. For example, 5,943 are there. 5,943 plus 1 divided by 2, which is 5,944 divided by 2, which is nothing but you are going to calculate that value, whatever the value it is approximately, right? So approximately the value is equal to 3,972, right? Sorry, 2,972. 2,972, right? So this position, whatever the value is there in this particular position, that is considered as the median for that data set, right? So now here, if it is an odd number, okay, sir, fine. But if you are having even number, immediately next question is even number. Now, if you keep the even number, 10 plus 1 divided by 2, which is nothing but 11 by 2, which is 5.5. There is no position of 5.5. There is a position of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are having 5th position, you are having 6th position. Where is 5.5 position means? Average of these two values we are going to take. Average of 5 and 6. 5.5 is the average of 5 and 6. 10.5 you got. Average of 10 and 11. 29.5 got, average of 29 and 30. 540.5 got, average of 540 and 541. Whatever the number you have got, this number and along with the second number. The average of these two we are going to consider. So whenever we are having the even numbers, the center two values average we are going to take. That is called as median. In this case, in this example, the center two positions are, I have got 5.5, which is the average of 50th position and 6th position. 154 plus 155, which is the average of these two. Median is 154.5. Is the median value. Is that clear? Median is clear. If you are having even number of data points, if you are having odd number of data points, just you are focusing on the center position value. Right? Next one is mean. Mean is nothing but sum of the data points divided by total number of data points. For example, here you are having with respect to the population data was given miss, then it is called as population mean. Sample data you are working miss, it is called as sample mean. Right? Now, generally the population, whatever the population parameters are there, whatever the population parameters we are having, they are represented by the Greek letters. They are represented by Greek letters. Mu, sigma, square, some by using these letters, which are Greek letters. Whereas sample statistic values are there. Sample statistic, whatever the sample statistic we are having, they are represented by English letters. Right? Now, mean. Here the mean is equal to sum of the data points divided by number of data points. Whenever you have to write the number of like this, but this shortcut in statistics is hash. Hash means number of. You don't need to write every time number dot no dot of. No need to write. Simply if you write hash means it is number of. In statistics, this is the representation of number of, because we are going to use multiple times number of. So they have created a shortcut for that. Hash indicates the number of data points. The number of data points. Right? Sum of the data points is represented by sigma. Sum is represented by sigma. This is meaning is sum. Remember guys, these all the things we are going to use in the machine learning and artificial intelligence also the same thing. The entire mathematical representation will remain constant. Right? So sum divided by number of data points. Sum of the data points divided by number of data points is called as mean. Right? Now here the first one is population mean. First size. Let us discuss before moving to the population mean. Keep the name as size. Okay. The population size is represented by caps lock n. Size is nothing but number of data points. Total number of data points. Total number of data points are called as size. Okay. So population size is represented by caps lock n. Sample size is represented by small n. Right? Now, whatever the mean we are having, mean is nothing but summation divided by total number of data points. If it is a population mean means given data is population data. For population data, you are calculating the population mean, which is given by mu is equal to sigma by caps lock n. Sample mean means for sample data. If you are calculating for a sample data, then it is represented by x bar, which is nothing but sigma by small n. Number of data points. Right? For example, I'm having a data set like this. 40, 41, 36, 39, 42, something. Now you are calculating the average value, the mean value. Okay. You are calculating the mean value. That is first is you are going to do the sum divided by total number of data points, whatever the data points. Okay. Before doing this one, whether it is a population data or sample data. If it is a population data, let us assume this is a population data. Then whatever the mean you have calculated is called as population. Let us assume this is a sample data. Then it is called as sample mean. Matter doesn't change, formula doesn't change. Just whatever the type of data. If it is a sample data means sample mean, population data means population mean. Right? Is that clear? And population mean is represented by caps lock mu, and sample mean is represented by x bar. Now you will ask immediately the question, sir, for the median, how we are going to represent? For median, there is no symbol. For median and mode, there are no symbols are there for them. Symbols are not available. Only for mean, only the symbol is available. Okay, population median or sample median, you have to use the word median only. There is no symbol for that. universal symbol is not available. You have to create your own symbol if you are interested, right? So mu, where the mu is with respect to population mean and x bar is sample mean. Formula is same. Just you have to add the sum of the data points divided by total number of data points, right? Now, next we are having the weighted average. So whatever the mean earlier we have discussed, whatever the mean we have discussed in the previous example, that is sum divided by total number of data points, which is nothing but is also called as arithmetic mean. This is also called as arithmetic mean. Okay, this arithmetic mean, and we are having one more type of mean is called as weighted mean. We are having weighted mean. Now, what is the difference between arithmetic mean versus weighted mean? Let us take a difference like this. Mean, some data points. Randomly, I'm writing data points 40, 29, 28, 21. Earlier you have seen, right? Now only, yeah. So the data, whatever the data, I'm taking some values 40, 30, 60, 20, 50. For calculation easy purpose, I have taken everything round figure, right? Now I'm having 5 data points like this. Now for these 5 data points, if you are applying the arithmetic mean, generally arithmetic mean is also simply called as mean only. Generally mean means arithmetic mean only. By default, arithmetic mean only. Okay, arithmetic mean, that is nothing but if you are applying the sum of the data points divided by total number of data points, that is sum of the data points are 40, 70, 130, 150, 200. 200 divided by 5. Sum is 200 and number of data points are 5, which is 40. Now, if you see here, basically this is having, what is the meaning of this one? The sum of the data points divided by total number of data points. Sum of data points. Let us take the data points as x1, x2, x3, x4, x5. Can I write x1 plus x2 plus x3 plus x4 plus x5 divided by 5? Now, the same thing can I write like this? 1 by 5 into x1, 1 by 5 into x2, 1 by 5 into x3, 1 by 5 into x4 plus 1 by 5 into x5. Can I write like this? Now, what is the meaning of this one means 1 by 5 is called as weight. So the weight of, for everything you are going to give the weight, whatever the weight is there, for everything you are giving the same weight, which is equal to 1 by n. That is 1 by 5 is the weight. For everything you are giving the same weightage. If the weightages are same, every data point is having the same weightage, then it is called as arithmetic mean. If the weightage of one data point is different, then it is called as weighted mean. Right? So let me explain in a simple way, still more simple way. Let us take a data set of 2 data points only, 2 data points. Let us take the first data point is your internal exam score out of 100, right? Out of 100, you have got internal exam 90, right? External exam, whatever the external exam you are having. In the external exam, you have got with respect to 80 out of 100. Okay. Now, if you cumulate these two, means you are giving us the same weightages for both of them. And if you take the average weightage is 90 plus 80 divided by 2, which is nothing but 170 divided by 2, which is 85. In this case, you have given the same weightage for both of them. That is 50% weightage for this one and 50% weightage for this one. Both of them are having the same weightage. Both of them are equal importance. This 90 and 80, whatever the score you have got, both of them are having equal importance. So you have taken both of them of equal importance, which is nothing but 1 by 2 into your 90 plus 1 by 2 into your 80, which is nothing but 45 plus 40, which is 85. This is the actual meaning of that. Both of them you have given the same weightages. For example, the same internal exam is 90 and the same external is 80, but this time the weightage of internal exam is 40%, weightage of external exam is 60%. Both of them are not having the same weightages. Then what is the meaning of this means? 0.4, whatever the weightage of this particular record, 0.4 into 90 plus 0.6 into 80. That is nothing but 0.4 into 90 is 36 marks of out of 50, plus this is 48, which is nothing but cumulative is 84. Is that clear? If the weightages are different, this is called as weighted mean and this is called as arithmetic mean. Arithmetic mean means you are having the same weightage for each record. For each record, same weightage is called as arithmetic mean. For each record, different weight is there means it is considered as weighted mean. In this case, you are going to divide by 0.5 plus 0.5. In this case, 0.4 plus 0.6. Denominator is 1 only. Sum of the weights. Is that clear? The difference between the arithmetic mean versus this one. For example, let us take one more example. 3 values are there. Let me explain clearly, because this weighted mean is going to play the important role in one of the algorithm. At that time, I'm not going to explain once again. Okay, I'm going to apply only. I'm not explain. Learning is here, application is there, right? So here I'm having 3 records. Let us take one more record also. 70. This is also 70, right? And one more record, 60. 60. Total 4 records are there. This 4 records and this one also 4 records. Now, what is arithmetic mean? Arithmetic mean means nothing but equal to your weightage mean, where weights of each record is 0.25. 0.25 into 90 plus 0.25 into 70. Arithmetic mean is equal to your weighted mean if all weights are equal. If all weights are equal. If all weights are equal, then there is no difference between both of them. Both are same, one and only same. Right? If you calculate 90 plus 70 plus 80 plus 60 divided by 4, the answer, whatever the answer you are going to get is 160, 240, 300 divided by 4, which is nothing but 75. You are going to get 75, right? If you say the same thing by applying the 0.25 into 90 plus 0.25 into 70 plus 0.25 into 80 plus 0.25 into 60 divided by 0.25 plus 0.25 plus 0.25 plus 0.25, which is nothing but summation of your sigma wx divided by sigma w. I am doing this one. Their weight into their value. So the weight is 0.25, 0.25, 0.25, 0.25. This is the weights. Just I am multiplying each record with its corresponding weights and divide by sum of the weights. Now, if you calculate this one also, the answer is going to be the same. For 0.25 into 90, which is nothing but 22.5. Which is nothing but 22.5 plus 0.25 into 70. What is the value of 0.25 into 70? 17.5 plus 0.25 into 80, which is nothing but 20. 0.25 into 60, which is nothing but 15. If you do the cumulative, which is also equal to 75. This one or this one, both are same. There will be no difference. Arithmetic mean is basically weighted mean only, where it is having the equal weightages. Okay. For example, this is having 30% weightage. This is having 20% weightage. This is having 40% weightage. And this is having 0.1 weightage. Or these 3 of them are having 0.3, 0.3, 0.3. One of them is having 0.1. Still, it is arithmetic mean only. If every one of the element is same only, 4 records are there, means 4 weights should be same. If one record weight also different also, it is not considered as arithmetic mean. All of them should be same. All, each and everything. If one of the weight is same or different also, you have to calculate the weighted mean. Right? In your exams, you are going to do this one only. That is nothing but your internal exam and external exam will have the different weightages. Suppose a midterm score 83 and final exam score is 95. For your midterm, I'm giving the 40% weightage. Right? For your midterm, I'm giving the 40% weightage. Okay, 40% weightage for your midterm and 60% weightage for your final exam. So 83 into 40. 95 into 60% weightage divided by 0.4 plus 0.6, which is nothing but 32 plus 57, which is 90. 90.2 is the answer, right? So here the weightages are important. That is the difference between weighted mean and arithmetic mean. Is that clear? Weighted mean and arithmetic mean. Any questions? Next, last one is mode. The last one we are having is called as mode. Mode means most repeated value. Most repeated value or most frequent value. Mode means most frequent value. What is the meaning of mode means most frequent value? Most repeated value. right? Sir, why weight? See, Mustafa, why weight means if you are having different weights, in that case, we are going to calculate. If you are having no weights means, then no need. So for example, in your university, you are having for both the internal exam and external exam, same weightages, then no difference. If internal exam and external exam are different, then different weightages only, right? Preparing only core Python is different. Preparation of core Python with Python for data science is different. Preparation of only core Python is different. Preparation of core Python plus Python for data science plus statistics is different. So for example, if I keep an exam on core Python, I'm going to keep an exam on core Python. You are writing one exam. Tomorrow you are going to write one exam. Assume example only. Okay. And next I'm going to keep one more exam on core Python plus Python for data science. This is a different exam. Core Python plus Python for data science plus statistics, one exam. Core Python plus Python for data science plus machine learning, one exam. I'm going to keep this exam. Okay. Me is Kaggle. Okay. Core Python plus Python for data science plus your statistics plus ML. 4 things you are going to prepare and writing the exam. Everything are same. Here you got 80% weightage, 80 marks. Here you got 80 marks. And here you got 80 marks. And here you got 80 marks. You see your preparation level is same. Getting off 80 marks here is very easy, but getting the 80 marks here is difficult. Right? So here the different weight is there. Miss, for that, some more things are there. So that is the reason. There we are going to consider the more weightage for that. Internal exam only writing two units only, right? At a time, 2 units or 3 units. Part of the syllabus only you are going to write in your internal exam. Whereas sectional, you are going to write the entire syllabus. So internal exam and external exam, both will be the same. How your slip test and unit test will be the same. Right? In same way. Done. Next, coming to the mode. Mode means most frequent or most repeated. In this case, which is getting repeated means 154 is repeated 3 times. So in my case, mode is 154. For example, let us take like this. Example number 1 is only one value is getting more number of times repeated. So just you have to write for each number 154, how many times repeated. Here in this data set, 154 is the first number. So I'm writing first number of 154. 154, 3 times repeated. Next, second number is 139. I'm going to check 139 how many times? Only one time. 154 already completed. 192, how many times? 2 times. 180, 1 time. 140, 1 time. 155, 1 time. So I'm having like this. Out of all of them, which number is getting repeated more number of times? Miss 154. Let us assume there is a data set. In that data set, I'm not having this particular number. Whatever the number I'm having, this particular number is not available. Without seeing this number, now again tell me the same answer. Now, how many times 154 repeated? 2 times. 139, 1 time. 192, 1 time. 180, 1 time. 140, 1 time. 151, 1 time. Now here, 154 was repeated 2 times. 192 also repeated 2 times. Both of them 2 times. So here, which is the mode means both of them are called as modes only. This is called as bimodal distribution. 2 modes are there in this example. Both of them are called as mode. Don't take the average of the mode. Don't take the average. Because why? Why you should not consider the average? Sir, earlier for median you told the average now. Why you can't take the average for this one also? Here it is a numerical data, but for example, discrete data, male, 4 males are there, 4 females are there. What is the mode means? Male plus female divided by 2. Transgender. No, right? No, right? So we can't do like that. So mode is generally applicable for the discrete data, not for the numerical data. Okay, most of the times we are going to apply this one on the discrete data. So for discrete data, we can't do the average value. So that is the reason we can't take with respect to this. So whenever we are having the 2 numbers or 2 things are getting repeated, it is called as bimodal. So for example, let us take one more example. Where in this same example, 139 is one more value is there. Assume. Now how many 139s are there? Miss 2 are there. Miss 3 are there. Now then it is called as 3 of them are called as modes only. Then it is called as multimodal. Multi means more than 2 modes. If you are having more than 2 modes, it is called as multimodal distribution. In the given data, we are having multi-modes. Multiple modes are available. If you are having only one mode, it is called as unimodal. Unimodal means mode is equal to 1. In the given data, only one mode is available. Bimodal means in the given data, 2 modes are there. Multimodal means multiple modes are there. Okay, let us take one more example. Like now in this example, let us take the example like this. This 154 is also not there. and this 192 is also not there. You are having only 1, 2, 3, 4, 5, 6. Out of all, 6 of them are unique only. You are having only 6 data. Out of 6 of them are unique. Everything are 1, 1, 1, 1, 1, 1 only. None of them got repeated. Second time also, none of them has got repeated. Now in this case, everyone are equal. Then in this case, it is called as no mode. There is no mode. For my data set, none of them has got repeated. I told you that a repetition, which is most repeated. No repetition is that means from where you get the mode. No repetition means no mode. Simple no mode. In this case, if you consider 180 also same answer, 139 also same. Yeah, as per your choice, you can consider. By default, it is going to consider the least value if it is a number. By default, it is going to consider first alphabet if it is a discrete variable. Actually, in the given data set, for example, I'm having like this. I have given only male and female. Only two are there. Records only 2. This is the data set. Only 2 records are there. The 2, one record is male, one record is female. And the column name is called as gender. Out of which I am having only one column with 2 records. Column is 1 and only 2 records are there, where the shape is 2, 1. 2 rows with 1 column. Right? This is the data frame. For this data frame, if I select df of gender, dot mode, by default, it will give the female as the answer. Because alphabetical wise, F comes first. It goes as per the alphabetical order. Basically, in this data set, there is no mode. In Python, at least one value it has to give, right? So by default, it is going to give the female, right? Is that clear, guys? Next, we are going to move on to the measures of spread or dispersion. Measures of spread or dispersion. It is also called as measures of dispersion. This we are going to discuss in the tomorrow's class.